Okay, so this is the fourth video in a video series of elementary number theory. So in this I'm going to discuss about the Euler tuition function properties. Okay, actually wait a minute. Alright, so some of the properties that is related to phi function are, that is, we can have the formula that we have already discussed. If you want, I can prove it. That is, take a number, for example, that the same number that we have here is the phi of p alpha. So that means we can write it as p alpha, the product of p divides p alpha, 1 minus 1 by p. That is, this p is the numbers which divide this p alpha. So from this we can write this p alpha is equal to 1 minus 1 by p. Alright, where we are considering this n equal to p alpha for the case. Now we have p alpha into p minus 1 by p, simple process for that. Now from that we can have p alpha minus 1 into p minus 1. Alright, that is, as p alpha we have p alpha, this can be written as p minus 1, and we have p minus 1. So from this we got this one, which should be added here, and then from here we can have this p alpha minus 1 into p minus p alpha minus 1, just multiplying this p alpha with p n minus 1. From this we get p alpha minus 1 plus 1 minus p alpha minus 1. From this we get p alpha minus p alpha minus 1. The formula for Euler phi function. This is one of the property of a Euler phi function. There is another property that we have here, is that phi of m into n equal to phi of m into phi of n into d divides this phi of d, where d is equal to the GCD of m comma n. So you have to use this and you have to prove this. So the proof is pretty much simple. You have to use your product formula over here, that is phi of m equal to phi of m by m equal to this product p divides m, that is 1 minus 1 by p. And for n we have same formula, that is p divides n, 1 minus 1 by p. These are 1 and 2 equation, and now we are applying this phi of mn by m into n. Since mn is getting divided by d, we can replace this mn by p of d, the product of d, p divides d, that when okay, I will show you. Okay, this p by m, and then we have 1 minus 1 by p into, just replacing this with 1 and 2 equations in this, with 1 minus 1 by p by p divides d, 1 minus 1 by p, as we know that d equal to m comma n. That is what we have assumed. Now we know that this right over here is equal to phi of m by m, right, and this right over here is equal to phi of n by n. Alright, now this right over here is equal to phi of d by d, since d divides m comma n. Alright, and yeah, now phi of m by m into phi of n by n. From this phi of d by d, from this we get phi of m into n equal to, okay, I don't know whether this thing is clearly visible or not, but I will do something for that in the future. Okay, we have phi of m into phi of n by m into n. Taking this upside, we will get d divides phi of d. We have phi of m into n is equal to phi of m into phi of n, d divides phi of d. So you can use this. Actually, this is also another formula for finding phi of some number n. So, and this will work for every number, whether it is completely multiplicative or not. Okay, I will show you what is completely multiplicative and not, the numbers which are completely multiplicative or not. For example, if I consider phi of 6 into 4, in a previous video I've told that the GCD of this 6 and 4 should be equal to 1, but in this case hence we conclude that this is completely right multiplicative. But we know that GCD of 6 and 4 is not 1. It is not equal to 1. It is equal to 2. The GCD of 6 and 4 equal to 2. 2 divides 4, 2 divides 6. So that means it is not multiplicative, not completely multiplicative. Alright. So if you try to solve that in that way, that is phi of 6 into phi of 4, you won't get this equal to phi of 6 into 4. Alright. Since it is not completely multiplicative, the condition for a completely multiplicative should be satisfied, that is the GCD of these two numbers. But the formula that we have here is will be applicable for every number. Now considering this phi of m into n, that is 6 that is phi of 24 can be written as phi of 6 into 4, where whatever you want to split, you can split in terms. Now 5, yeah, I'm dealing with 6 with m, and 6 into 5 4 into d. The GCD of 6 and 4 is 2 and phi of 2. Alright, so we got the smaller numbers in terms of this formula. By this formula, even if we don't get the smaller numbers, you can again apply the formula for this 6 into 2 into 3. Alright, you can do it at the side if you want it, or else check whether this 6 is completely multiplicative or not. So we know that phi of 6, the GCD of 6 is 2, hence we can say that the GCD of 6 so not the 6, just 6, the GCD of 6 can represent 2 into 3, so the GCD of 2 and 3 is 1, so hence we can say that this phi of 6 is completely multiplicative. We can apply the formula, that is phi of 2 into phi of 3. These are prime numbers, so we 1 into 1 into 2, sorry, 1 into 2 we get 2, so we get phi of 6 equal to 2. Or else you can use the same formula that is that we have just now derived. You can do it, but it will take time, so that's why I'm not going to do that, but you can do it. It is pretty much easy, you know that, right? 5 6 we got 2, 5 4 we know already that we have already find this 2 2, and phi of 2 is 1. Since phi of 2 is equal to 1, we get 2 2 2 8. Alright, so the phi of 24, it will be equal to 8. So we got this by using this formula. And one more condition that we have here is property for our phi function, that is or the same condition, but to be precisely speaking, where the GCD of m comma n is equal to 1, then we can reduce phi of m into phi of n into 1, since since the d divides m, d divides n, phi of d, in place of d we are adding 1, phi of d equal to 1, so hence we got this formula. From where we got this formula? From here, right from here. So this is how we got the completely multiplicative function and formula. And one more property that I want to include here is that if a divides b, that implies phi of a divides phi of b. Alright, let me write the question first. Actually, you can follow those two properties from the textbook. Those are pretty much easy. You can, if you do go through, you can get it. Now I'm going to start the drinchlet product of of arithmetic functions, and there are some properties for drinchlet product. How do you write it? I will first show that. You write the drinchlet product of a number. This is how the drinchlet product should look. That is, if you consider f star g, this is star g of n, you can write the drinchlet product of f and g as d divides n f of d into g of n by d. You can write it in this way. And since this drinchlet product has a property called commutative, you can write this as summation. Alright. G of d into f of n by d. From this we will get g star f of n. Or you can follow that from the textbook. And drinchlet product also is associative. So there is a easy proof which is given in your textbook. You can follow from there. I didn't think so I have to add anything here. Actually, this can also be written as f of a into g of b, and this can also be written as f of this is function g of a and f of b. So from this implies that these both are same. So from this we can write g star f equal f star g. Rest is easy. You can find you just have to prove associative property, that is this one, that is f star this one f star g star k equal to f star g star k. That's it. You can use instead, in place of g star f star, in place of g star k, whatever you want to take, you can use this and prove this, or you can use this and prove this. Take the value for g star k equal to some a and a, then consider this f star a. You will get f star a, right? If you're considering g star k. Now add the function. Now find the, it will be equal to f of the same thing, f of a into a of b. So we will get the values for g star k. This a is nothing but g star k, right? So we will get the summation. I'm not adding this summation. You can add it afterwards. It will take, it is time consuming, that's why. F of a this is not g, this is a, f of a and b. I have used this. So f of a into, inside place g star k of d. So using this d, now f of a, you can have this bracket. This is summation. We have g of b into k of c, taking some random numbers. Now from this you will get all these are equal. Since multiplication is commutative, you will get f of a, g of b into k of c. From this you can have f star g star k. That's it. Actually, there is a proper steps is given in your textbook. You can follow from that. I've just given the idea behind that problem. Now we have another concept, which is arithmetic function. This was the Dirichlet product, and we got to know that Dirichlet product is commutative, Dirichlet product is associative, right? Now we have another concept, that is arithmetic function, which it says that I star f will be equal to f star I will be equal to f. I will act as an identity, and we're using the Dirichlet product over here for finding this I star f or f star I, whatever you want to take, you can take. For example, if I take f star I of n, so you can write it as summation of d I of n by d, where d divides n. Alright, from this basically this fd is nothing but like this. It will be like this: f1 1 by n plus so on, plus f of n 1 by n, sorry, n by n up to n by n. So basically you will get f of d divides n, since I will act as inverse, since I of n by d will be equal to 1 by n by d, will become d by n. So just replacing this with that. Now there is a condition which is given for arithmetic function, which is a definition or the property, that is whenever d divides n, we have, or any number which divides n, n divides any number, 0 1 if n is greater than d, if n equal to d. So the only non-zero number for this in the series will be this n, but the rest of the numbers will be equal to 0. Alright, from this we get that from this we will get f of n. Now if you consider this I star f, the same thing will go with this, that is, if you consider I star f of n, you will get id summation d divides n f of n by d, and from this you will get summation 1 by d, since I will inverse this, and we have n by d. Alright, since 1 by d equal to 0, we get fn by d. Also we get fn by d here in the previous case. Okay, wait a minute. From here we get that from the condition that is given, that if n is greater than 0, 0 1 if n is greater than n is equal to d. So if I consider that is d is greater than 1, you will get this term equal to 0. Alright, if you consider d equal to n equal to d, in this case d divides n, so we will get this 1 equal to 1, this entire term will become 1, and then we will get f of n by d. So this is nothing but, we have used this, right, I star f of n will be equal to f of n. That's it. This will prove the theorem for this both. We got the answer for both. Alright, now the next theorem that we have here is that Drinchlet inverse, and then the next after that we have Mobius inversion formula, and by this we will end the topic of Drinchlet product, and from this we will go to multiplicative functions, and if you observe that, you can understand them easily, so you can do it by yourself. And you have to use the same concept here. In that complete in multiplicative functions, there is one theorem that I want to highlight, which most of the students get confused in that, and then after that we'll go for multiplicative functions. We know that after that we have Engel function, and then divisors functions, and these are very much easy. I will just explain them very briefly. Before that, we have two problems, that is drinchlet inverse and mobius inversion formula. Alright. Okay, I will stopping the video. Let me write the question. Okay, so you have to keep that in mind. This might come in your examination. In theorem question, it might include this or not. So you have to remember that this is a condition or the property of a drinchlet inverse. So you have to use the drinchlet product formula that we have discussed just now. Now first we are taking this, right, proving this I. Alright. So we have f of 1 which is not equal to 0, so considering this n equal to 1, so we have f star f inverse of n equal to I of n. Alright, that is, you can write it as, to be precisely, d divides 1 f of 1 f inverse of 1 by d, that will be equal to I of 1 equal to 1, as 1 divides 1, f inverse of 1 by d equal to f inverse of 1 by 1, that will be equal to f inverse of 1. Alright, so from this we got f1 and f inverse 1. I have explained this right over here. From this I got f of 1 and f inverse of 1 equal to 1. Since it is in place of n, we have taken n equal to 1. Alright, so we got 1, and then from here we have f inverse of 1 equal to 1 by f of 1. Alright, so by this we have proved that it has a unique solution for f inverse of n. So f inverse of n will be equal to 1 by f inverse of n. This is what we have proved. Now the first part we have proved. Now we have to prove the or take this condition and generalize it. Right, that is, take this condition, there is f star f inverse of n equal to I of n. Alright, the same thing that we have to apply the drinchlet product for the d divides n. We have f of n by d into f inverse of d equal to 0 if in equal to 0, if in equal to 0 for every n is greater than, for every n greater than 1, because this is we got it from in, that is, previously I have already stated that if n is greater than 1, if 0 if 1 if n is equal to 1, if 0 if n is greater than 1. So from this we are assuming that for n is greater than 1, as we want to generalize it. So we got this. Now from here, what we can do, if I consider adding this f of 1 into f inverse of n, this whole thing will become 1 because previously we have seen it. In place of 1 I have selected 1, so f inverse n, this will become 1, or 1 identity. So the value for a is, it does not matter if I add that, f of n by d, f inverse of d equal to 0. Now what I can do here, that I can just send this value to this right hand side, and I will end up having the question. Here is the question, right? That is f inverse n. This f inverse n, we have f inverse n, we got f inverse n, and then we have f of 1 is in multiplication, sending this to other side. After we send this to other side, first we will send this to other side, it will become minus of this one, we get the value for this, alright, with minus 1, and then we have f of 1, we will get it as minus 1 by f of 1, so we get the drinchlet inverse theorem. And over here, for proper steps, step by step, you can follow your textbook. Now there is another function, arithmetic function u, defined by u of n equal to 1, where it says that mu star u will be equal to I. There is a small proof for that, you have to keep that in mind. Basically it says that mu star u will be equal to 1 I, sorry, not I. So basically you can say that u equal to mu inverse. So mu inverse will be equal to u, or u inverse will be equal to mu. Now Mobius inversion formula. Mobius inversion. Alright, in this Mobius inversion, the same thing that you have to do is the statement will be equal to f of n, where d divides n is given. Now that implies you have to prove g of n equal to summation f of the mu of n by d, right? Now you have to, this implies this and this implies this, so not taking this, using this and proving this. Alright, considering f of n, the summation g of d into 1. Can I write it into 1? Right? Yeah, I can write. And summation d divides n g of d. Can I replace this one with u of n by d? Since previously we have seen that u of n by d will be nothing but equal to 1 if n equal to d. Alright, there is just a common function that I have used here. If n is not equal to 1, if n is greater than 1, you will get 0 for that. I have taken it from the definition of in. Alright, so I can replace this with that, because as you can see, we have to get this, right, n by d of mu of n by d. So the only thing that we could do is use this function u of n by d, and then as we want mu, so we can multiply this function with mu, right? From there we have f of n, so from there we can write f of n equal to g star u, alright, of n if you want to add. From this you can write f equal to g star u. Now multiply this f with mu star mu, G star u star mu. Since we know that drinchlet product is associative, it holds associative property we can have. And also one more thing, that is u star mu. Previously I've said that mu star u are both inverse of each other, so that we can get I. Alright, now keep that in mind. If I change the parentheses, u and g star u star mu, I will end up having u star equal to g star I. Alright, now from this I can have f star mu equal to g, which implies that f star u equal to g of n. Alright, from this we can have this, that is g of n will be equal to summation of t mu of n by d. So by this I have explained the Mobius inversion formula, and you can also do the converse of it, and you can do it by yourself. Take this and prove this. For this you have to keep that in mind, that you want to get this g of d, right? G of d here, you want to keep this thing, and you just have to eliminate this. So how do you eliminate this? By multiplying or star by using the u. That is, you can write it g equal to f star u. Now multiply both sides by u. Oh sorry, Drinchlet multiplication of u on both sides. You will get u. From this this part right away will become 1. Alright, I, it will become I. We will end up having f this side, and we will end up having g star u this side. Since we know that u of n by d equal to 1 if n equal to d, if d equal to n, sorry. So this is a pretty much problem about Mobius inversion formula. Okay guys, so it's been like 3 hours, maybe 3 or 4 hours since this video, since this I'm recording this video, and I get a bit tired. Alright, we have multiplicative functions. The topics that are left here is that multiplicative functions and some of the theorems in it. If f is multiplicative, then f of 1 equal to 1. If it's in there, so there is a short proof for that, and it is easy, you can do it by yourself. And there is another theorem that says that f of some n can be written as product primes will be equal to f of p1, so on, f of pk, since f is multiplicative. And also this is easy, you can do it by yourself. Alright, f and g are multiplicative, and then there are Dirichlet product of f star g is also. If f and g are multiplicative function, then you have to prove that the Dirichlet product of these two is also multiplicative. Alright, so for that you have to consider two numbers, that is f star g of m into n. Since you're considering two numbers, and then we can say that these numbers have relatively prime condition, and then we can get this f of this is easy, I can show you. H of mn f star g of m into n. You have to find this, right? Will be equal to basically f of m star g of n. You have to prove this, right? You have to use and you have to prove this. Okay, I will prove it. Okay, so D is the GCD of m comma n, so you can, from this you can get m by D and n by, no sorry, okay, one more thing that I want to add here. D is equal to a comma b, and a divides m, b divides n. The GCD of a comma b equal to 1. Okay, 1. Then you can write m by a, since a divides m, and b divides n, b is dividing n, and the GCD of a comma b is 1. We got this 1-to-1 correspondence between the set of product and divisors of d of mn. Now using this hm n is equal to summation a by a divides m, b divides n. This is a f of a comma b, the drinchlet product. We are applying the drinchlet product over here to this one. From this we can get summation a by m, sorry, before that, b by n. From this f of a, f of b, I can write g of m by a, g of n by b. Alright, from this implied, considering this specific for a divides m, considering this f of a, and this from here g of m by a. Now considering this b of n, summation b of n, b divides n, f of b, g of n by b. Alright, from this we get h of n, h of n. Alright, so this was pretty much easy. And there is one more theorem which confused most of the people. I will try to explain that. Alright, let me take a rest. Alright, so the theorem is that it is like g and f star g are multiplicative. Then what we have to prove? F is also multiplicative. We have to prove this theorem by using contradiction method. Okay. Okay. We are proving this theorem by contradiction. Like, for example, if f is not multiplicative, like assume that f is not multiplicative, that means we cannot have this condition satisfied. Alright, that means f of m into n is not equal to f of m comma n, even though if there is m comma n equal to 1. Alright, like for example, consider this, since f of 1 cannot be equal to f of 1, it will not be equal to this. For example, h of mn, considering this mn, h of f1, f of 1 into g of 1. Since g is multiplicative, we get 1, and f of 1 is not equal to 1. From this implies that h of mn is not equal to h of m, not equal to h of m into h of n. Alright, now this condition is containing the theorem by assuming that the m and n, the values of m and n is greater than 1. Alright, considering the drinchlet product for this, that is summation d divides mn, f of d, g of mn by d. Alright, so in place of d I can replace with in place of d I can write since just since these since we are considering the GCD of a and B is D, D divides this A and B. Sorry, A and B divides D. That implies A and B divides Mn. Sorry for that. A and B, G of. Now one more thing that I can add in this sequence is that f of m and g of 1, this entire will become 1. Alright, since we are considering that this h of mn is drinchlet product, so f of mn n into g of 1 will become 1. Alright, so from this I can write the same problem, previous one. Alright, and then this is f of m. Since we know that g of 1 equal to 1, and we are not certainly sure that f of m by n, f of m into n is equal to 1. Yeah. Alright, and we can write this as no, g of 1, this is equal to 1, right? So it will become 1. Now that is basically we got this, right? Now here, before that, I will write this mn in summation a by m, b by n, since we have separated these all, right? F of a into f of b. Alright, g of m by a, g of n by b plus f of m into n, that is equal to 1. Now adding and subtracting minus f of m into f of n plus f of m into f of n in this. Alright, adding and subtracting f of m, f of n. Alright, so what we are doing here is adding and subtracting this f of m and into f of n. After that we will end up having this part right over here is preserved, and then after adding and subtracting this part right over here, the plus of f of m and f of n will become 0, and then we will end up having this f of mn minus f of m into f of n. Since that we want to prove that h of mn is equal to h of m into h of n, we have to make this part forcefully. We have to put this part right over here, which is not multiplicative, will be equal to 0. But since this f of mn is not multiplicative, we won't get it done. So for this we have to we've got a contradiction, since we assume that f is not multiplicative. So from that we can say that f is multiplicative. Alright, by this I'm gonna end up the session for number theory. If you want, I can explain this Mangold function and Mangold function, and then this is Liouville's function is not that much not big deal. It's a small function, and then we have divisors function and sum of divisors function. These are all easy. Hope I could complete this in some other topic some other time. And then we also have congruences, basic congruences, and then Chinese remainder theorem, all these linear congruences, quadratic congruences. There are so many topics in number theory, but right now I don't have time to do that, explaining that. but this is to be honest, this is pretty much the entire unit from which I have covered the topics. These are the topics that I have covered. That is divisibility rules, GCD, theorems on GCD, and then fundamental theorem of arithmetics, and then I also explained the Euclidean algorithm, and also I've explained the arithmetic function, drinchlet multiplication, mobius function, Euler function, relation between these two, and then I also explained the drinchlet inverse, mobius inverse, drinchlet product of arithmetic function. These are pretty much topic that has been covered from the elementary number theory. Hope if I get the time, I could explain the congruences, basic congruences, like Lagrange's theorem in the polynomial congruences, Euler format theorem, and Chinese remainder theorem, polynomial congruences, and also quadratic reciprocity law and quadratic residues. They're all related to each other, right? If you understand from what I have explained, then please help my channel to grow up, and also motivate me to motivate me for more such videos. And thanks for the patience that you've got, and thank you very much for watching my videos, and please share with others as well. Okay, bye.